Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Raspberry Chocolate Swirl by Katie Splendor, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have index lines, where on the dark pink index lines, the digit in the nth cell along the line, starting from the diamond, indicates the position along the line where the digit n appears. For example, 3214 would be a valid line. So let's just take the first 4 digits of this cell here. So if we had 3214, that would be valid because the first digit, 3, indicates that the third digit is a 1. The 2 indicates the second digit is a 2. The 1 here in the third position means that the first position has to have a 3. And the 4 in the fourth position indicates the fourth digit is a 4. So that's why that would work. So that's an example of how an index line works. We have ratio crop keys, where digits separated by a black crop key dot have a ratio of 2 to 1, and there is no negative constraint. So, for example, if this were a 2 here, this would have to be a 1 or 4 to maintain a 1 to 2 ratio, because there's a black crop key dot between them, which is a ratio crop key. And we have sum dots, where the 2 digits or 4 digits surrounding a brown sum dot, which is, I guess, a chocolate swirl, adds up to the value in the middle of the sum dot. And repeats are allowed if available by other rules. So, for example, these 4 digits must add up to 20. So you could have, say, 3, 7, and 3, 7, and that would be valid, because the 4 digits surrounding the sum dot would add up to 20, which is the sum in the middle of that sum dot. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so on index lines, the digits that can be on the index lines are from 1 to the length of the index line, right? Because you can never have, essentially, any index line which is going to be... You can't be pointing to a number that's outside of the length of it, right? So on a line, so in the first position, that digit is where the 1 is going to have to be. And obviously you can't go past the end of the index line. So that's why all the digits for 5 length index line must be from 1 through 5. So this must be 1 through 5. And this has to be 1 through 3 here, because there's only 3 on that line. So this 1, 2, 3 triplet eliminates 1, 2, 3 in the rest of the box. So this becomes a 4, 5 pair, which means 2 must be in the 4th position on this index line, and 3 has to be in the 5th position. 2 and 3 have to be in the 4th or the 5th positions on this index line. So this can't be 2 or 3. It's 1. That eliminates 1 here. So this is 2, 3 as a pair. 1, 4, 5 eliminates 1, 4, 5 in the rest of the column. And 1, 4, 5 eliminates 1, 4, 5 in the rest of the index line. So this is 2, 3 as a pair. That eliminates 2, 3 in the rest of the column. Well, what can be in the 2nd position and what can be in the 3rd position here? 1 cannot be in the 1st position. 1 can't be in the 2nd position because of 1 in the column. So this must be a 3 then. So this has to be 3, which makes this 2. That eliminates 3 and 2 on the rest of this line, because you can't have them both. You can't have 2 digits that repeat be on the same line, because that would be saying that the digit x has to be in both of those positions. So say we had a repeat of the 3 on this index line. Well, that would say that 3 has to be in the third position, has to be a 1, and say we had a 3 here. That would say 3, both 5 and 1 would have to be in the third position, which is not allowed. So in the third position must be a 1. So this is a 1 here. That eliminates 1 from the rest of this index line. Remaining digits, 3 is in a 1 to 2 ratio with 6, so this must be 6 there. That leaves the remaining digits as 7, 8, and 9, and 7 and 9 cannot be next to a black crop key dot, because it's the same with 5. 5, 7, and 9 are the digits in normal Sudoku which cannot be next to a black crop key dot, because if you have 5, 7, or 9, you get 2.5, 3.5, and 4.5. If you double 5, 7, or 9, you get 10, 14, or 18, none of which are digits. So this must be 8 here, and this is a 7, 9 pair. This 8 signifies that 2 has to be in the 8th position, so this must be 2, which is in a 1 to 2 ratio with 1 and 4. For 8 isn't only in a 1 to 2 ratio with 4, so that's saying that 3 has to be in the 4th position, so this is a 3. 1 cannot be... 1 can be here. Remaining digits in this left central box are 1, 5, and 6. These have to add up to 10. And these are in a 1 to 2 ratio. Well, if this is 4 and 2, that adds up to 6, which means these must add up to 4. And the only 2 digits which can add up to 4 would be 1 and 3 if they're unique, which they have to be because they're in the same box. But we can't have a 3 here because of 3 in the column. So this cannot be 4 and 2 adding up. This must be 4 and 3 adding up, which means the remaining digits must add up to 3, which is a 1, 2 pair. 3 eliminates 3 in the rest of this row, so this can't be 3. Where is 3 on this index line? It has to be here, which means 5 has to be in the third position. So this is 5, which leaves just a 4 remaining on this index line. 3 eliminates 3 here, so this is 2. 3 here means 5 has to be in the third position, so that's 5, which makes that 4. Remaining digits in this lower left-hand box are 6 through 9. Remaining digits in column 4 are 6 through 9, and again, this can't be 7 or 9 because 5, 7, and 9 cannot be next to a black crop key dot. Remaining digits in the central box are 6, 7, 8, and 9. This can't be 8 because of 8 in the row. We have a 6, 7, 8, 9 quadruplet in row 6, which eliminates 6, 7, 8, 9 in the rest of the row. So this has to be 3 and 4 with 1 or 5 here. Well, 3 and 4 cannot appear on this index line here, so they have to both appear here. Which means this 3 and 4 have to be in the first, second, or third position on this index line. So this must be 1 or 3. 4 has to be in the first or second position on this index line. So that's 1 or 2 there. We have to have a 6 somewhere here. The 6 on this index line is either here or here, which eliminates 6 of the rest of this box. So these can't be 6 anymore. It has to be 8 here, which is in 1 to 2 ratio only with 4. That eliminates 8 from the rest of the row and column. And the 7, 9 pair eliminates 7, 9 in the rest of this column. So this must be 6 here. That eliminates 6 in the rest of the box here. These 2 digits add up to 7. So it's either 1, 6 or 2, 5 here. 1, 6 or 2, 5. This can't be 5 here because of 5 in the column. This can't be 6 here because we need a 6 on this index line. So this is 1, 2 here, and this is 5 or 6. So 5 can only be in the 5th or the 6th position on this index line. So this is 5 or 6. That eliminates 5 and 6 in the rest of this index line. So 4 has to be in the 2nd position because we need a 2 somewhere on this index line, and this is the only one that can be 2. So that's 2, which makes this 1 and 6 to add up to 7. That leaves this as a 5. That means we are just left with a 3 in this lower central box. So this says that 5 has to be in the 6th position. 6 is this saying 6 has to be in the 5th position. This is saying 4 has to be in the 2nd position, so that's 4. We have a 1, 3 pair here in row 6, which eliminates 1 and 3 in the rest of the row, so no 1 here. It's 5. That eliminates 5 from the rest of the box. This is 1, 6 as a pair. That eliminates 1 and 6 in the rest of the column. These are in a 1 to 2 ratio. We can have 1, 2 if 2 is here. So we have 2 and 1 there. We can have 2 and 4 if 2 is here. That's 2 and 4. 3 and 6 cannot be here because of 3's in the row. And we could have 4, 8 if this can't be 4 and 8. So this is guaranteed to be a 2 here. To be in a 1 to 2 ratio. 2 eliminates 2 here, so this is 1 and 2 there. 1 eliminates 1 here, so it's 6 and 1. That 6 is saying 1 has to be in the 6th position, so this is 1 there. And the remaining digits on this line are 5, 7, and 9. Okay. And this can't be 5 because of the 4, 5 pair in the box. We're guaranteed a 5 somewhere on this line. So this cannot be 5 here, which makes that a 4, which makes this not 4, so that's 5. So 3 says 1 has to be in the 3rd position, 2 says 2 is in the 2nd position, 1 says 3 is in the 1st position, 4 is in the 4th position, 5 is in the 5th position. We have a 1, 4 pair here. These two digits add up to 11. It cannot be 2 because of 2's in the column here. Can't be 4 because of 4 in the column, so it can't be 3 because of 3's in the rows here. So no 2, 9, no 3, 8, no 4, 7, so it must be 5 and 6, and this can't be 6 because of 6 in the row. So this is 5, which makes that 6. These 4 digits add up to 26, and we have 1, 2, 3, 4 here in this box. So 26 plus 10 is 36, and 45 minus 36 is 9. So this must be 9 here, which eliminates 9 here, so it's 7 and 9. 9 eliminates 9 here, so this is a 7, 8 pair. That eliminates 7, 8 in the rest of the box, so no 7 there, it's 9. That leaves this as 7. And this must be a 6, 8 pair. This can't be 6 because of 6 in the column, so that's 8 and 6. 4 eliminates 4 here, so that's 1, which makes this 4. 9 eliminates 9 here, so it's 7. That's saying 5 has to be in the 7th position. So this must be 5, and this must be 9 then. 7 eliminates 7 here, so it's 8 and 7. This already adds up to 16. 29 minus 16 is 13. So these two must add up to 13, therefore must be a 6, 7 pair. That eliminates 6, 7 in the rest of the box, so this can't be 6 or 7, it's 9. That leaves this as an 8. Okay, we have 8 ones. We know where the last... No, we don't. We have 7 ones. Never mind. Okay, remaining digits of column 3. We have 5 and 8. 5 cannot be here because of 5 in the row, so this is 8 and 5. That gives us 7 digits in row 3, so we're left with 8 and 9. 9 can't be here because of 9 in the box, so this is 8, that's 9. The rest are just remaining digits of column 1. We have 4 and 7. This can't be 4 because of 4 in the row, so that's 7 and 4. Remaining digits of column 5. We have 2 and 6. This can't be 6 because of 6 in the row, so that's 2, which makes that 6. That leaves the remaining digit in row 2 as an 8. Remaining digit in this upper central box as a 9. Okay, remaining digits of row 1 are 3 and 7. This can't be 7 because of 7 in the column, so that's 3, which makes that 7. 3 in the corner, we celebrate because we're close to solving it. 3 eliminates 3 here, so that's 1, which makes this not 1, so that's 3. 1 is in the first position, 2 is in the fourth position, 3 is in the third position, 4 is in the second position, 5 is in the sixth position, 6 is in the fifth position here. These 4 digits add up to 13. We have 10 here already. That's 12, so this must be 1 here. Remaining digits in column 7. We have 6 and 8. This can't be 8 because of 8 in the row, so this must be 6, which makes that 8. 6 eliminates 6 here, so it's 7 and 6. 7 eliminates 7 here, so it's 9 and 7. Remaining digits of row 7, we have 4 and 9. This can't be 4 because of 4 in the column, so we have 9 and 4. Remaining digits of column 8, we have 3 and 7. This can't be 7 because of 7 in the rows, so this is 3, that's 7. 3 eliminates 3 here, so that's 2 and 3, which leaves us as 2 and 5, with 3 celebrating in the corner. So that's pretty straightforward, I feel. Index lines are fairly, well, they can be kind of complex, but there are a lot of restrictions that go along with them. So along the lines, yeah, they that they can never be greater than the length of the line. The digits on the line can never be greater than the length of the line, and each one has to appear once essentially. You can't have repeats on the index lines. Though there can be some interesting variations on that, if that is possible. I didn't even check that this adds up to 20. But it does. So we didn't even use this clue here. Interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.